All right. Welcome to the session on the Columnstore. My name is Sunil Agarwal. I'm a program manager with SQL Server team. And with me, I have our esteemed customer, Aaron. He works for FIS. He's a vice president there. And I am really honored that he's here because he's using the technology I'm going to talk about in their production workload. So it gives you a warm and fuzzy feeling that this technology is being used by Aaron and by other customers as well, okay? So Columnstore is not something new to Microsoft. How many of you have heard about Columnstore? 50 to 60%, that's good. It's a pretty amazing technology when you talk about data warehouse, okay? And what we did with 2016, and we improved that in 2017 as well, is to create a scenario where you can do analytics in real time, okay? Now, what does that mean? I'm going to touch upon that point, okay? So before I begin, our request to you all is please fill out the survey and evaluation thing. Helps us quite a bit. So agenda for today is actually a combination of two talks. HTAP. This is a hybrid transactional analytical processing, a lot of words. If you search Google, you will find HTAP is a very official term. It is also called real-time operational analytics, okay? So to start off, let me pose a scenario to you, okay? It's a simple example, but it works well. So imagine you own a world's largest grocery store. Let's say just you own that, right? And we're talking Walmart into 30,000. I mean, like big store, right? Okay. Now you are selling, perishable goods like milk and the meat and cheese and whatever not. You're also selling non-perishable items, okay? Now, let's say today your store manager comes and says, we have 20,000 bottles of milk that are expiring today, okay? Somebody told you that. The question is, what will you do? It's not a tricky question, simple question. What will you do? If you were the big guy and 20,000 milk bottles will expire today, sell by today, what will you do? Sorry? Junk. Yeah, I mean, sell by today. So I won't junk it until tonight, right? Yeah, you put on sale, right? So that makes sense, right? I put on sale, hopefully I will get more items out of my store and I get some money. But if I told you that you are selling 2,000 bottles every hour, let's say I told you that kind of analytics, then you say, wait, if it is 2,000 bottles every hour, maybe I should not put on sale. It will get sold, right? So the point I'm making is, this kind of analytics, I'm giving a very simple example, can give you an edge in your business to get more revenue, right? If you were going to use yesterday's data for the analytics, you won't know how things were selling every 5 minutes or every hour. You see my point? So the thing is, we are finding more and more businesses are looking for the real-time analytics. As transactional workload is happening, they want to analyze at the same time. And that gives them an advantage from the operational perspective, okay? So that's the scenario. Now, so HTAP is a scenario that we enabled in 2016. And we will talk about strategies, how HTAP scenario runs in SQL Server, because the last thing people want is to compromise their transactional workload, right? I mean, I could do analytics on my transactional workload, but if it slows down my transactional workload, I don't want it. I want to not compromise the performance of my transactional workload. You imagine that, right? If my analytics, which is complex, if it slows down my transactions, I lose business, okay? So that's the trick. And then we have a customer success story. Aaron is going to talk about how they use the HTAP technology from 2016 successfully for their business. And then this is something very interesting. I've been running the Columnstore feature for 3 years now, and I talked to a lot of customers. And what I find is they're getting good performance with Columnstore. It's no-brainer. Okay, they get good performance. But I find in many cases they're not getting the best performance. There are some gotchas. So I will go through some of those gotchas and what you can do about it. And they're applicable both for HTAP, even for data warehouse. Okay, so that's pretty much the agenda. Okay, so this is how traditionally analytics was done. You have, for example, a transactional system, right? You are running your, just think of a grocery store. You are going to the counter, buying stuff. In this case, this person is buying flowers, right? And then it goes into a database, transactional database. In this case, it is SQL Server. And then what people do, they don't want to run analytics on that transactional system. What they do is they do a ETL, right? Nightly ETL or hourly ETL, so that you can do analytics in isolation from your transactional workload, right? So let's say I do the ETL, and we land into a SQL Server data warehouse, and then you can run the query. For example, the query here says, show me this quantity, how the quantity is going down on an hourly basis. So I can figure out this commodity that I was concerned about, how it is selling, right? Now the problem with this solution is, it is not the current one. It is week old. It could be day old. So that information is not going to help me decide what's happening today in my system, right? Now the thing is, this architecture, anybody has this kind of an architecture in their organization? A lot of us. And the reason is very obvious, because transactional workload is holy cow. You don't want to overload complex analytics queries, because if you do that, it will do a lot of IOs, it will take CPU power, it will drown your transactional workload, right? So people don't do it. So this is the state of the art before Columnstore came along, okay? So I just wanted to give you the motivation why this was the technology and why it stayed. I think this is, people have been using this for 20 plus years. That's how they've been doing it, right? So what we have changed, okay? So I'm going to show you in this case, okay? So I think it is an important point. This thing works, right? This thing works, but there are complexities. For example, it is a complex implementation because you have a transactional workload here, you have an analytics workload here, and you do ETL. Anybody thinks ETL is easy? Anybody thinks? Okay, very few, right? ETL is very complex, because how do you figure out what changed since the last ETL? You have to do transformation. You see my point? ETL is a complex application. So it is is a very complex system in general, right? So let's say you say, well, I have it implemented, complexity taken care of. Why should I worry about it, right? But the key point is, you are paying more money. You have two licenses of the product, right? SQL Server for transactional workload and SQL Server for data warehouse, right? You're paying more money. You have more hardware, more things to manage. Your DBA will be more busy, right? All those things are there. But even if I have the money, but the problem is your analytics is not current, right? And as I said, more and more businesses want to respond to the trends in a timely manner, which is real time, if they can, all right? So that's the challenge with this technology, all right? So how does Columnstore solve that problem? So I have a very, very simple demo that I wanted to show to you, just to show the power, why we are changing that paradigm, okay? Why? So here I have a query which I'm going to run in this database. You guys can see in the back? Okay. Let me see this, okay? Hold on. Make it a little bigger, so 100%, okay. So I'm going to just I'm going to run this query, okay? Now notice in this query, I have a fact table, fact sales table. And I have 3-dimension tables. When you look at analytics in a traditional way, it is created using a star schema or the snowflake schema, right? And I know there are a lot of data warehouses which are not star schema, not snowflake, because they grew organically, okay? But let's not worry about that point. The point is, this is a 3-join query. It's a reasonably complex query. Let me run this query. This is running like it would run without Columnstore. Okay, so I'm going to run it. And I simplified the date. I'm just querying from 2006 to 2007. It's not a whole lot of data. And this query will finish for me around in 10 seconds. Okay, that's my prediction. It's not holding on. Okay, 13 seconds. In the conference room, it is 13 seconds. Okay, it took 13 seconds. Not bad, right? Okay. Now, all I have to do if I want to speed up my analytics, and here's the key, I can just create a clustered column store index on it. Okay, so this is pretty much what I'm doing. I go here, I'm just creating a clustered column store index. When you create an index, we have all created indexes in our applications, right? Does it change the application? No, it does not, right? You create indexes to speed up. So that's what I did. I just created a clustered column store index. That's the magic, right? And now what happens is I'm going to run the same query that I just ran, and I come here, and the only difference that you will see that I have a table here. I changed the name to whatever table it was before. I said it is that underscore CCI. I have 2 copies because I did not want to create the column store index while talking to you, right? So that's all I did. And now I'm going to run the same query, and this query will run. I didn't even finish. It finished, right? So column store, and we'll go into why it is such a powerful concept. It is not Microsoft. Column store is not Microsoft. Column store came out of universities. Oracle, DB2, HANA, everybody has column store. The real question is my column store better than your column store? And I think we believe Microsoft column store is the leading technology today. We do a lot of benchmarks. We are leading there, okay? So you see that, right? Without doing anything, I was able to run this like this. Now, it takes less resources and runs my query much, much faster. So at least column store is allowing me or giving me an opportunity where I can do or even think of doing the real-time operational analytics, right? Because the trick is, could I run it with a minimal or 0 impact on my transactional workload? And I'm going to convince you how we achieve that, okay? Okay, so that's where we are. So let me switch back to the slides. Okay. So now what happens is, with the column store, I'm going to show you this guy first. So same workload like before, same workload, right? What I'm going to do is I'm going to create a column store index on it. Like the tables that I was running on my transactional workload, all I do is create a column store index, just one more index, okay? And now what happens is I can run the queries directly on my transactional system, okay? Directly on my transactional system. Now the beauty is, if you sold a glass of milk or bottle of milk, it shows up in the transactional system, right? And I can do analytics on it, right? So that means no latency. Do you see any other benefits of that? I know it's afternoon, make it interactive. Yeah, any other benefits? You eliminated one license for SQL Server, right? Not good for me, but it is good, right? It is good. Number 2, you did not buy one machine, right? And the best of all, no ETL, right? Because I'm running thing right there. Now you may wonder, some of you may be very deep into this technology. The transactional workload schema is not normalized for data warehouse, okay? So there'll be a lot more joins. So the query performance may not be meeting your expectation, okay? There is no magic. I mean, we don't do magic. The point is, you have a technology now where you have a way to get the real-time analytics, maybe a little bit slower. If it's not running in 1 second, may run in 2 seconds, but you get the latest data, right? That's the key value. You don't have to wait for a day to get the information. I hope I have convinced you on that point that real-time operational analytics, if it works, is a good thing. You agree? And Aaron is here to show it works, okay? So that's very important. Okay, so I'm just going to skip through this one. You pretty much understand what I'm saying. So now what I want to do is I'll just take a very, very simple slide to show you how this magic is happening, because this is a magic at some level, right? So what Columnstore does, to a person who does not know a whole lot about it, it can give you approximately 10 times decompression. So if you have a terabyte data warehouse today, you can compress it to 100 gigabyte. I mean, that's a big deal, right? Now, not only you get compression, you can speed up the queries. In my case, it showed up around 10x, right? But you know, the query performance in analytics is the size of data, right? If you have a lot of data, you will see the difference even more exponential. We have seen a lot of workloads speed up 20x, 30x, and some queries, I mean, I cannot believe myself, 300 times faster than before. So it's insane, okay? It's insane. So that's what this technology gives you. So how does it happen? How does it happen? I think I have a very simple visual to bring you guys to earth, like this is no magic, this is how it is happening. So what happens is, with Columnstore, remember I said create Columnstore index? You know, when you have a row store, what is the deal? You have rows, let's say you have a 50 column table. How many columns will you have in a row then? You'll have 50 columns, right? One row, next row, third row, fourth row, page is full. You go to the next page. You go to the next page, right? Okay. In Columnstore, we are not storing data of all the columns together. We are storing them. Each column is stored independently, okay? That's pretty much it. Now, the beauty is, if each column is stored independently, you can get much better compression, right? Like all of us, where are we attending the conference? In Florida. So let's say the state is Florida. So everybody of us has a Florida as one of the columns. Now with Columnstore, I have to store Florida only once, right? So you can see how the compression happens. So that means your I/O will be 10 times faster or lower. Not only that, your data stays compressed in memory. So your memory requirement will be appropriately reduced. Or if you want to keep the same memory, now you can put more data. So if the data was not in memory for your next query, guess what? There is a higher probability today it will be, right? Okay. So that is good thing in itself. But the most important thing is this. People do analytics not on 50 columns. People do analytics on given this product for this quarter, whatever not, right? They do a subset of columns. Columnstore, because these guys are stored independently, I only have to fetch the columns that are needed in the query. Okay, so let's give you an example. Let's say you had 100 units of I/O before you create Columnstore, 100 units of I/O for the query. Now I create a Columnstore index. My I/O will reduce to 10 units, right? Because I got 10 times compression. I'm just talking about average. And if I was going to access out of 50 only 5 columns, that means I'm accessing only 10% of the data, right? So the 10 becomes 1, right? Because 10% of 10 is 1. So essentially you have reduced your I/O by 99x, right? That kind of stuff. So it can give you much, much better performance. That's the magic. That's the magic, right? Now the last thing that we have done, this is unique to Microsoft, is when you place an order in Amazon, all of us have done it. You buy 2 or 3 items, right? Tomorrow you go and check the status of your order. Has it been shipped, right? That means you're dealing with few rows. Agree? But with analytics, you're not dealing with few rows. You're dealing with millions, even billions of rows, right? Show me, because if I have a very successful company, let's say I'm Amazon, I'm selling, I wouldn't be surprised, billion orders a week, maybe more, maybe, I don't know, right? If they are doing analytics, they are munching through a lot of data. Now, what we do with Columnstore is we don't process one value at a time. We process in a set. That is called batch mode processing. I'm just going to stop on this place because thing is, these are the magic. So this is how Columnstore is working. Okay. Now, these 2 concepts that I'm going to talk about, row group is an important one because it will be used in the example that I'm going to give. Imagine this, you have billion rows, okay, and you have 50 columns, okay. Each column, how many values will have? Assume everything was distinct. Each column will have how many values? Billion values. There are billion rows. Agree? Nothing. Now, if I imagine this data that I have billion rows, it is order entry. Like I did 10 million orders today, some other orders yesterday, right? Okay. Now, if I was going to look for orders that were filed in the last 1 week, okay, I don't want to read the data that is older than 1 week. Agree? Because that will be a waste of time for me. All right. So what we do is inside the column store, we break these values in a unit of million values. You will ask, what is so special about million, right? We did some heuristics and we found million values give you decent amount of compression. Okay. So now what happens is you will have, and that unit we call a row group. So each row group will have each column, right? And then you have multiple row groups, right? Okay. Now the trick of running the query faster would be to eliminate row groups. You don't have to read all the row groups. You agree, right? If I was looking for data for last 1 week and I have sales data for 10 years, I don't want to read data that is older than 10 years, right? Okay. So that's the key point, okay? Second thing which is important is each column that we are storing in a row group is stored independently, because that's the deal, right? Each column is independent, okay? Now, here is something we do which is very, very important. For each segment, this is a segment, we store minimum and the maximum value. It tells me that this has min value of this much and this is maximum. And why it is important? If you had sales data that is date based, sales data is coming on the date order, right? It can tell me, if I was looking for the last 10 days, it will tell me what is the max and what is the min date on this million values, right? So I can easily eliminate. Very, very important concept, okay. All right. So this is pretty much what it is, okay? I'm going to go, this slide we have seen. I'm going to go to now how. So you understand the concept, right? So I'm going to talk about two things. One is the HTAP scenario. So what happens is, imagine this. You have a transactional workload, and you have a bunch of traditional B-tree indexes, right? They are cluster index, they could be non-cluster index, right? Okay. Now, if you run analytics on using these indexes, it will be very expensive, like we showed, right? So now with Columnstore, all you have to do is create a non-clustered index, which we call Columnstore. So think of it, you're not doing any surgery, you're just creating one more index, okay? And what we found was, when you create a Columnstore index, some of the indexes that you have created for faster query may not be needed, okay? So you may in fact end up dropping 2 or 3 indexes that were just there for query, because Columnstore can run a lot of queries faster. So in a good case, you replace 3 indexes by 1, which means your transaction throughput will benefit, right? Because when I insert a row, I have 2 less indexes to insert the row in, right? Okay. So that's that is, right? Now, interesting thing that I'm trying to say is that this thing that you see, which are like in red, these are compressed. These are compressed, okay? The one in blue are not compressed. And what is this magic? And this is important for performance. Imagine this, right? I'm inserting orders as they are coming, okay? If I insert one order, can I compress it? I can't really compress one order. I need million values to compress. So what we do is, inside, we collect large number of values, which happens to be million. Once it crosses the threshold, there's a background process which converts the blue guy to red guy. It's just happening behind the scene automatically, okay? So this is the delta store. So the only point I want to impress here is, if you run a query on a blue guy compared to red guy, which will be faster? If I run a query, red guy. So if your index, Columnstore index, has a lot of blue guys, it is trouble, okay? That is one of the reasons why query performance with Columnstore may not work to your expectation. And we call, if you have a lot of blue guys, it means your index is fragmented. I'm going to talk about that point, all right? Okay. Now, I'm going to skip the point about this delete and delete buffer. It is a little bit of a deep point, but key point is these red guys are read-only. They're read-only. So if you update a row that was already compressed, you can't really delete it, update it, because imagine this, if it is compressed, how do I update it? I have to decompress it, change the value, and recompress it. You agree? And it'll be very expensive. And if you are running transactional workload, update will become insanely slow, right? Okay, so we don't update in place. They are read-only, and we track the deleted rows through another structure. Okay, so the column store is a very complex structure, and good thing is you don't have to worry about it. This is something our development team has to worry about. So that's going on. Okay, so this is that. So now all you have to do is, if you want real-time HTAP scenario, you just create a non-cluster column store index. In a good case, you may have to drop certain other indexes, right, which are not needed anymore. No changes to your transactional workload, right? It's not a surprise. When you create an index, there is no change. And now SQL Server Optimizer will automatically, if you run a query that is analytics, like give me average, give me what, it will pick the right index behind the scene. You don't have to worry about it. So now your transactional workload runs as is, and your analytics runs through the column store. Okay, so that is the scenario. Now, you may ask, let me go back here. You may ask, well, you know what? I have extra index. If I insert a row here, I have to insert in this blue guy as well, right? So there is an overhead. There is an overhead. There is no doubt about that. I don't want to pay that overhead. Let's say you say that I don't want to pay that overhead, right? So what do you do? In some cases, these are the tricks we support. Now, go back to Amazon example. So you check your order. One order has arrived. Do you go and query that order that much? When the order has been fulfilled, at some level it becomes cold. Agree? Order is hot when you placed it because you may want to change it, whatever not. Once it is shipped to your door, it becomes cold, right? So what I could do in theory, I can say, create a filtered, non-clustered column store index. What it means is, create a non-clustered index where job status or my order status is arrived. That means I'm going to create a column store index only on those rows which have already arrived at my house. They have become cold, right? Now it means is the hot data is not paying any overhead on the column store. Agree? Okay, so this is the trick we provide. You may wonder, okay, if there's no column store here, how do I get real-time operational analytics? Because I want to do analytics even on this guy, right? Because that is real time. Agree? So behind the scene, SQL Server, when you run the query, it will use these guys, and this guy, and give you the result. Okay? That's how it does real-time analytics. Okay? So that is one trick we do. Now a lot of people say, I'm going to just skip this guy. A lot of people say, you know what? I don't have this, order arrived status. That means I have to change my application. And in many cases, I can't really create a column which is not suitable for my application. Okay. So what we talked to customers was, what is a typical pattern between hot data and cold data? So what I heard was that a lot of data becomes hot for a short duration, and then it becomes cold. Okay. So let's say it is hot for 4 hours, it becomes cold. Stays hot for 1 day, it becomes cold. Okay. So we said, okay, we will provide an option. You say, create a column store index, and do not compress this blue guy into the compressed guy for 30 minutes. In this case, my data stays hot for 30 minutes. You can go up to a week here, right? So essentially what we are saying is, now you can control hot and cold data. The beauty of this one is, remember, updating here is impossible. But this blue guy is like a row store. I can update in place. So the impact that you have on your transactional workload to update or delete is much lower with this scenario. You agree on this point? Okay. So this is another thing we provide as part of minimizing the impact on the transactional workload while still giving you the HTAP scenario. Agree? Okay. You guys are not asking any questions. I'm assuming I'm getting through. Is that a fair? Okay. All right. Two thumbs up. Okay, thank you. On two different sides, it helps. Okay, so this is all good. Now, think about this. Even if I have all these things, yes, my transactional workload is not paying the cost. But when I run my analytics, is it running on the same box where you're running a transactional workload? Agree? It will cause I/O. It will cause CPU. What do you do? Now, I'm not saying everybody has always on, but a lot of mission critical workloads have high availability option where they have the transactional workload, because if it is so critical to you, what happens if that node goes down? You want that application to be available, right? So now what you could do is you create a non-cluster column store index here and run all the analytics here. So all the query processing / CPUs happening outside. So if I think of a best case, if you had a hot, cold data like order arrived, you are not paying any cost on the transactional workload. I'm not saying that's common, but that's the best case, okay? Now, I'm going to stop here. And so what happened when we were working with this technology, we work with a lot of customers to make sure this technology is addressing the scenario that we were developing, right? And Aaron, Aaron should talk about that. Me and Aaron worked very closely to understand their business problem and how Columnstore can solve that. And Aaron's going to talk about that problem. Yeah.
Thanks, Sunil. Hi, everyone. As Sunil said, I work at FIS. Which, if you haven't heard of it, it's actually based here in Florida, up in Jacksonville. More than 50,000 employees, and we're one of the largest fintech companies. I'll flip ahead to. So we're selling software and technology solutions into the financial services space, banks, everything, retail banks up to investment banks, hedge funds, insurance companies, and the like. And it's a real pleasure to present here about our success story. Like Sunil said, I'm up here to basically tell you, yeah, it does work, right? And it can be as simple as some of those slides that he presented. At least it was in our case. So that's what I'll describe. The product that I work on at FIS, it happens to be focused on market data, financial market data, in particular the securities lending market. And a lot of people haven't heard of that, but it's a pretty active, pretty large market, about $2 trillion in daily volume. So behind the scenes, we've got like a few terabytes of data, historical, going back 12 years, that we let our clients tap into and provide a lot of analytics on that. But over the last few years, we've also started to process in real-time data. So we've got streaming data. And that's where we saw an enhancement opportunity potential. So our clients use our application to sort of slice and dice and this data and find trading opportunities, market intelligence, or even just check what's the latest price or stock loan rate on this transaction. So you can imagine you're on the trading desk, you type in, you want to look, you're going to borrow Microsoft stock. You type in MSFT, and you want to see immediately what's going on in the market, this securities lending market, for that stock. It's similar to like if you're looking up stock prices, but it's just borrowing and lending those shares. So the enhancement opportunity potential here is enhancing the real-time analytics, because once we started getting those real-time data points in, we're doing fairly simple things with them. What's the average, what's the high, what's the low, but not really pushing insights to the user, what's getting hot, or more broad-based analytics. So ultimately, that's where we wanted to go. We wanted to provide what we would call a real-time dashboard for either the whole market or for their entire trading program, so they can see how their trading performance is doing in real time, and what opportunities are evolving in real time, not just look up FIS or MSFT one at a time. So our starting point, and it really is a similar starting point to the one that was described earlier, right? Traditional row store setup for transactional processing, and then on that larger 12 years of data, a traditional data warehouse model, a lot of ETL, nightly batches for the end of day files, and then what I like to call like little mini ETL batches every few minutes on the real-time data, but still not getting us to the point where we could support that real-time dashboard. And on the real-time side of things, it's important for this case study here, we're talking about 1.2 million daily transactions, so not quite at that Amazon scale. And so this isn't the biggest example of the power of hybrid transactional analytical processing, but it's maybe one of the smaller examples, but it still, I think, shows that it has great power even in these scenarios. So like I said, our application can display rich analytics on our historical data, even as of what happened yesterday. In your milk example, lots of analytics on what would have happened, what were your previous trends in selling milk over the, yesterday, the days before. But in terms of real time, more limited. So we want to take that to the next level. But it's not so easy, right? What were the options that we were thinking about? Well, we could extend that traditional ETL model, data warehousing model, into the real time, but then what are we going to do that every second, right? Every 10 seconds? It's going to put a burden on the transactional workload, so that's probably a non-starter. And any extra ETL that we'd have to do like that is just going to complicate our workflow. We're really looking to simplify at this point, not make things even more complex. And if we do go down that path, because maybe it was necessary, we would determine, then we know that the application development is also going to be impacted as well. So now we realize we have like 10 different widgets or analytics and charts that we want to show on this dashboard. There might be 5 or 6 different new customized tables with dedicated aggregates in each one, like a top 10 hottest securities table or a counterparty risk score table. And now the application developers and query writers need to know, okay, for this query, I'm going to go to this table. For that query, I'm going to go to that table. It gets more complex versus what if they could just write a good query, always pointed at the one primary transactional source. And then ultimately, latency is going to be included if we're adding in these delays of mini batches and so on. So those are the challenges we're facing. But then we hear about real-time operational analytics and some of the new enhancements related to Columnstore index technology in SQL Server 2016 and now 17. And that's where we started to work with Sunil and his team and found a really good outcome. So in our case, we looked at the non-clustered Columnstore index, and we got excellent query performance. I'll show you some numbers in just a minute. And true to form, no impact on the transactional processing. It was great. And it's just so simple to set up. You saw I think the earlier example was a clustered Columnstore index, but it's basically the same thing. Create non-clustered Columnstore index. I think I got the syntax right, but it's basically that simple. And in our case, we did do like a hot and cold filter thing. So when we're bringing in new transactions from all of our market participants, we do mainly like transformation of the data, like not normalizing in a relational sense, but standardizing different security identifiers. Someone might give us one identifier, another one gives us a different, and we use our own common identifier. So while we're quickly transforming that, we set those records off to the side. They're filtered out, so they're hot. They would be addressed by the traditional B-tree index if you're querying. But everything else is cold. It's ripe for analytics, so it goes into this non-clustered Columnstore index. So just, really simple. The queries, like I said, we had, before we even started applying the index, I was working with one of my colleagues, Xingfei Gong, and he and I would write these queries, we get them ready to go, and we know how slow they're running on our row store table. Then we apply this new Columnstore index on it. We didn't have to change anything. It's the same query. So you can imagine if you're in a scenario where you have a dashboard today or a report today that's running slowly on this transactional data, if your scenario is similar to the one that I was facing or we were exploring, in this non-cluster columns or index, it could just very well be the same query, right? Not go to this section of, use this index with a hint or something like that. Just really simple for us. And then the second point on these slides here, it has mentioned the forcing compression. So as was just mentioned a second ago, the automatic compression, as I understand it, it kicks in around 1 million new rows. I think it compresses things at the start, but we kind of start at 0 and then get 1, 2, 3, right? We build up those 1.2 million transactions during the day. So to take full advantage, we said, well, why don't we do I think it's a reorganize command to force the compression. Basically, it's kind of like rebuild index, but it's reorganize. And it just compresses it. It happens on the fly. It's an online operation. Nothing skips a beat. Nothing goes offline. And for us, honestly, it was more of just like a preventative measure. It wasn't really like, I'll show you a slide where, as we add in new records, are we seeing decreased analytical performance? No. But maybe eventually, if we get up to 2 million, would we? So why don't we just compress every so often? We figured 100,000 rows seemed like a good approach. So we put that in there to try to round out the solution. And we did look at the other flavor of Columnstore indexes, the clustered. And as mentioned, that's really good for like your data warehouse scenario. And the cool thing about that is you can apply it to in-memory OLTP tables, so a memory optimized table, and then use the power of the natively compiled stored procedures. So that looked really attractive because you could get kind of insane performance on some of those queries. And we did try that. We got some very fast performance as well. But for us, going those few extra steps, it added a bit to the complexity of the solution, and we were looking for something just really simple, really easy, something like creating an index, and the non-clustered Columnstore index was literally just creating an index, so that's the one we went with. And the other one with the in-memory and not compiled procedures, it was working well, but it wasn't, in our particular example with only 1.2 million rows, it wasn't light years ahead or anything, so it didn't really push us over the limit. And also, if you're going to go the whole route of natively compiled procedures, not every query that you have today could work exactly the same. Like, for example, a case statement. There's a workaround for that because it doesn't directly compile at this point into the native C. So it depends on what you're doing in those queries. Some of them, like, count up the number of transactions for this group. Boom, no problem. But then, case when, you have to do a workaround. So again, it was just a layer of complexity that we said, well, we don't need it. Non-cluster Columnstore index is working great for us. Let's stick with that. So I'll show you some of the results. Some of those might be a little small, so I'll just mention the rough numbers here. And what we're looking at, this table has some of the typical queries we were executing in this dashboard, and comparing the results of the non-cluster Columnstore index performance in milliseconds compared to the traditional row store. And like the first one, 18.5 times the row store versus the Columnstore. So that, tremendous performance gain just by creating an index. And that is like a classic, I would describe it as a classic high-level aggregate, right? Sum of everything in a particular range, or count of everything in a particular range. Then when we get to some of these other queries, you're still looking at either 2 times or 5 times, 13 times. We start doing things a little bit fancier, maybe joins to 2 or 3 other tables, cross databases. We start grouping by either numeric or varchar columns. So get more complex. And so we see different results. And there was one query where we didn't see any performance difference, the 0.9, so roughly equal. So it's not, Sunil would always tell me, this isn't a silver bullet. It's not going to, solve all of your problems. So we didn't gain in that particular query. But, if we add up all the milliseconds we saved in the other queries, we're light years away. And in fact, that's the next table. This is measuring count of seconds, or sum of seconds, for this whole group of queries, so about 20 or so queries that we would run on one big dashboard. We kind of decided, if we're going to do this, let's throw the kitchen sink at it, and how many possible metrics would somebody want to see in real time for securities lending? And you can see in the blue line at the top, it's taking like 11 seconds to complete one refresh of that dashboard. Way too slow. But then just by applying this index, the non-clustered Columnstore index, we bring it down 2 to 3 seconds. So 4 times faster performance just with that index. So again, very different queries, different performance level, and also different size of data. Like in our case, we're talking about roughly 1 million records, or sometimes even less in the early parts of the day. So if you're dealing with even tens of millions or a billion, you might see even bigger performance. But this is what we work with, so we were very happy that we could get to a point where in a couple seconds we could refresh an admittedly like overly complex dashboard. But really, once we boil it down to like the essentials, or just some of these things don't need to be refreshed every few seconds. Maybe those could be every minute. Now we're talking about sub-second refresh on a dashboard, something we just couldn't do with the traditional setup. So just in closing, I mentioned we do have our case study published on the Microsoft website, so you can read a little bit more about it there. And basically, the pull quote on the cover of that, I think, sums it up well. Because it just speaks to the simplicity and the performance gains from this type of technology. You just apply the index, and you get 10, 20, 4 times, whatever the case may be, better performance on this tricky challenge of real-time analytics. So thanks. Thank you, Sunil.
Yeah. Thank you. Any questions for Rel on this? So we have, yeah.
Actually, I have one. I can set the microphone so we can hear you. But how did you implement this? Was it just like, Sunil said start creating indexes, so we're going to go on our production system, and bam, 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 and all of a sudden you're getting calls going, what's going on? Because obviously you're going to prove this out before you.
Oh, yeah.
So how did you approach the implementation of this?
Yeah, I can't even get to our production systems. So, yeah. Oh, sure. Yeah, the question was, how do we start proving this thing out, right? And it's a good one. We can't just go to the production system and just, hey, what happens if we turn this index on? Does everything just run faster, right? I like to say in the good old days we used to be able to, but those days are long gone. So yeah, the approach that we took, and we were lucky enough to be working with Sunil early on when we had some questions about, wait, what is this new technology that's just coming out? And like he said, this was like in preview stage at the time. And FIS is a Microsoft partner, so we can we can leverage each other in that way. So the first thing, honestly, we had to do was make sure we had a development server running SQL Server 2016. And in fact, we had to make sure the operating system was 2012, R2. So, because we didn't have that yet. We were actually in the process of converting over, but our dev environment wasn't there yet. So, we got that set up, but it wasn't too difficult. I think I was actually doing it on my laptop before I was doing it on the dev machine. But once we got it up and running, basically just, bring in the data, like say, some production data, copy it down or create some samples. And then, like I said, we knew what we wanted this dashboard to contain, so we had our queries. And then it was a matter of just understanding what exactly is this magic behind the Columnstore index. And I'll be honest, I wouldn't be able to explain all that stuff that Sunil was explaining earlier, right, about exactly how it all works with the pages and everything. But once we realize how simple it is to create this index, what's the syntax, what that filter option might be used for, how the compression factors into it. I don't know. I mean, I look back, it's almost as simple as like just applying a regular index now. It's like, yeah.
One follow-up question, if I may. How did you simulate your production workloads in the dev environment? So if we have technology like this, that's one of our hardest challenges. We have people in dev, but there's no way we're going to get a true production scenario out of a dev environment when it's like, hey, you know, Bob, Joe, Steve, and Mike are all in on Saturday hammering away at this and it's running great, but that's not 1.2 million, you know, records in an 8-hour span. So.
Yeah, I don't know if there's any special tools out there that could help with that. We just kind of took an old-fashioned approach, a little bit of elbow grease, and we kind of use it for our development anyway, where we have we can store like a whole day of actual data, or even double it up if we want to, you know, expand the size, future-proof it, right? And we use like SQL agent jobs and things like that to simulate that same data coming in, maybe even in the same order or twice as fast or something like that. So we just kind of create our own little old-fashioned queue and start pushing it through our system, but otherwise have all the other, you know, triggers or whatever ready to go.
Yeah. So I think one thing I would say, I want to get on to the second part of the presentation. There is a tool called Database Experiment Assistant. Essentially what it is, it's a layer sitting between the production box, and it sends the same queries to your test environment. So there is one way you can do it. This is something coming out of Microsoft. Okay, Aaron, thank you so much. So the next thing, and this is something that I have learned over time, that people expect Columnstore to perform, and it does. But the point is, in many cases, customers are not getting the best performance possible. So there are many cases. I just took 5 representative examples. So the format of this presentation is 1 slide, 1 demo. So you will be able to sort of understand in real sense what's going on, right? Now the statistics, right? All of us know about statistics, right? Query optimizer needs statistics to create a good query plan, right? It's not a mystery. Now, here is something that is not so obvious about Columnstore. You know, when we create a Columnstore index, we do not specify any key columns. Just take a minute to think about. Whenever you create an index, you create key columns, right? With Columnstore, there is no key columns. And you say, why? Think about this, right? If I was inserting rows, let's say key was C1, 1, 5, 10, I got million rows inserted, 1, 5, 10, 15, so on and so forth. Now you come and insert value 4. Just think about that. How? I mean, I have to decompress the data, right? Because I can't, in a compressed value, I just cannot go insert in between. You see what I'm saying? So the key point is there is no key column, okay? So now what happens is when we create a Columnstore index, there is no statistics created on that index. So if you have 50 columns, you create a Columnstore index, no stats. But if you had a traditional non-clustered index, you're creating on column C1, because we need to sort on column C1, right? So we know all the values, so we will get that, right? Okay. So a lot of people come and say, you know what, I created a Columnstore index, I ran this query, it runs so slow, right? And they sometimes give up. And sometimes, well, if you run it again, it runs faster because stats got created automatically. So that is one example. Second example, which is interesting, a lot of people load a lot of data every night. And there's a threshold that triggers in the new update of stats. So a lot of people say, you know what, things were running fine last night. I loaded the data, and my query ran slow. Now, so you understand what's going on, because stats are getting computed. Now, what is so big deal about stats? Well, Columnstore data is not like million rows or 2 million rows. I mean, in this case, for Aaron, it was not a whole lot. But customers that we have worked with, they have hundreds of millions, billions. In fact, one customer I worked, and I'm not lying here, 150 billion rows. Okay, it was partitioned. It has to be partitioned. Okay, that much. Okay, so that is the important point. There is no stat. So what happens is, the stats need to be computed, and it has to recompile, and it can take time, and that adds up to your execution. All right. So what can you do? Well, I mean, we talked about that. So any idea what we could do? I mean, I'm sure all of you have some level of expertise in the stats management. One thing you could do, you can say after I load my data or create my index, I just run manually create my statistics. Once I'm done, okay, ready for prime time, right? Okay, you can do that. You can also do something interesting. You can say my stats will be updated automatically, but async. What it means is when query optimizer runs the query, it knows stats are out of date, but it will create the query plan using heuristics without the stats and fire a thread in the background to get the stats. So next time when you come around, it will do it. Okay. So that's nothing major here, but it is something actually very interesting because a lot of people don't realize that point, and I wanted to sort of impress upon here. So I have some demos, and the good thing about these demos is I can stop at any slide because the time runs out because I have 5 demos. So I'm just going to go through each of them. And my request to you is, if you have questions, just ask me, because I think if you keep it interactive, we will get more out of it. Okay, so I'm going to get Object Explorer. I'm going to lock it here. Okay, so what I have is a AdventureWorks database. You guys can see, right? Read in the back. Everything is good? Or I can, okay, let me just do this. Okay. All right, and what I did was I copied my rows from the existing fact table that I had into a temporary table for this demo. And by the way, this AdventureWorks thing that you see, you can download from our download site. So it's not something that is my special. It is available for you guys, okay? So I just create the cluster column store index. And then what I do is, if I go to the table, which is in this case, if you look at it here, it is, I think the table is fact reseller CCI underscore temp. My naming is horrible, just bear with it, but I mean, that's what I have, okay? So if I go here, and I look at the stats, I refresh, okay. So let me just do one more time, refresh. So notice there is no stats right now. I just created a column store index. If you look at that guy, it is just a dummy guy. There is nothing in there. Okay. So I'm going to run this query, the query that I have. I drop my stats, and I'm going to enable this thing on, the stats time on, and I'm going to run it. So I'm running the query, which is the same complex query that I ran before, right? Now, remember the first query ran a little faster? Remember when I ran it last time? It ran under a second or something, right? It took 3 or 4 seconds, right? You would say, well, my row store ran in 8 seconds, and you ran in 4 seconds. I mean, column store is only 2x faster. I'm not interested, right? So that is the point I'm making. So when I ran it, and what happened now is if I go and look at my stats, and I go back here, refresh, stats got created in the background, right? And those stats are expensive because we have to sample the data, okay? So that takes time. Now, if I look at my messages, you will see that, oh, did I run it again? Okay. Just give me a second. I don't know what went wrong here. And I'm going to show the properties. Okay. So I see. So what happened here is, I think I'm running my stats in an async mode. So stats got created, but I ran the query like that, right? Now if I run the query again, and notice when I ran the query, the CPU will be taken to create the stats, right? So I'm not getting all the CPU power that I had on my machine. Now if I run this again, you will see this query will go faster. You see that? So this is the example I wanted to show you that this can happen. And this can happen when you do data load. In fact, a customer I was working with, they had a partition table. they load a lot of data, okay? So when the load data comes into that partition, the next time when they run the query, the stats have to be updated and it gets messy, all right? So it's very, very simple example that I wanted to show you, okay? Now the second example I want to show you is fragmentation, all right? How many of you have dealt with index fragmentation? I think I would imagine everybody, right? I mean, just some of you are not just saying, okay, everybody. Now the index fragmentation for Columnstore is a little different. Remember, I have blue guys and red guys. Remember, blue guys was row store and red guy was Columnstore. Do I care about fragmentation in the blue guy? Do I care? I don't think I care, and the reason is this. The blue guy will be wiped out. After a million rows, it will be compressed. Blue guy will be history. So I don't care about fragmentation in the blue guy. I care about fragmentation in the red guy. You are with me on that? Now what is the fragmentation? Because it is read-only data. The fragmentation in the red guy is you have a lot of deleted rows. So imagine now you run a query. We have to run the query on the red guy and then subtract the rows that have been deleted, right? We have to do an anti-semi-join on that. It gets complex, right? The query performance over time will tank, right? And so that's the index fragmentation. So diagnosis is a lot of deleted rows, and we expose that information. I'll show you in the demo. And the second diagnosis, which is actually very interesting, if you have highly concurrent inserts going on, you have like IoT scenario where you are getting data from multiple devices, okay? In many cases, because of high concurrency, we create multiple blue guys to insert the rows. Okay, we don't push all the rows into one blue guy. There will be multiple blue guys. You're with me, right, when I'm saying blue guys? And now what happens is, suddenly you have a column store index with lots of blue guys, and analytics does not run well on the blue guys. Agree? So that is another scenario. You have a explosion of blue guys. In fact, there was a bug in our code back in 2015, and it's not even funny. We have 10,000 plus blue guys. I mean, the query performance was gone, and we couldn't figure out how we got so many, and we found the bug, yeah. But it can happen even in a normal course of processing, right? So we understand that point. So what you can do, you run index defragmentation. So first thing you have to figure out, is index fragmented? If it is, which means a lot of deleted rows, then you can say, I'm going to run alternate index reorganize. This is the same command that you run on your traditional B-tree indexes. And behind the scene, it does the magic. It will not remove, if you have only one deleted row, it will not worry about that, because that's too much work. It has some sort of a heuristic. It will remove the deleted rows, okay? So that's the deal. So what I want to show you in a demo is I have intentionally fragmented an index, okay? I just want to show you how it looks like, okay? So I'm going to open. And I go here. And by the way, I'm going to make all these demos available on the website. And if you want, happy to mail it to you, all right? So index fragmentation. Okay. So here is what I did. I'm just playing around with these guys. So I went to my database, and I created a empty table, and I'm calling it the big name underscore frag, because this is my fragmentation demo, all right? And what I do in this one is I create a column store index. Remember, I load the data. I only loaded 4 million rows because I just want to show you the concept. I could have loaded all the rows, but I said only 4 million rows. Okay. And then I create a column store index. So when I create a column store index, everything will be compressed, right? And now what I did was, if I look at the row groups, row groups will be all compressed. Then what I did was, I updated every other row. I ran this command. I knew this key column. I said, okay, update every other row. So now what happened? Update in column store is done not in place, because we cannot. We already solved that problem, right? We cannot do in place. What we do is we delete the row and insert the updated row into the blue guy. Got it? So the red guy will say this row is deleted even though you updated it, but row exists in its new incarnation in the blue guy. All right? So what you got is 4 million rows. The blue guy will have how many rows? Around 2 million rows. Right? And the red guy will have 2 million rows marked deleted. Your query performance will not be a happy thing. Right? Okay, so that's what I did. Now, typically people don't do that with Columnstore, but I'm just trying to show you it can happen. It can happen. Okay. So here, so I have updated when I came here. I'm going to show you. Okay. So here's an interesting thing which I want to take a minute to explain to you. I think I will do on the screen so that people here can see. See, notice this guy says open and closed. Agree? There are 2 row groups which have approximately 2 million rows. One is open, one is closed. But these open and closed are blue guys. Closed means that blue guy already has million rows. Open guy does not have million rows. All right? Everything else is compressed. You see that? Right? Any questions? Okay, so this is, okay. And notice deleted rows, see, insane amount of deleted rows. Now what I'm going to do is I'm going to run a query. I'm saying set statistics time on, and I'm just going to run a average of something. So now what is happening is 50% of my processing will be somewhat faster because it is going against a red guy. When I'm saying somewhat, because it has to subtract the deleted guys, right? It won't be the fastest. And then there are red, blue guys, right? So the query performance will be slow. In this case, I mean, it got over in 1 second, 4 million rows. I mean, not a big deal for Columnstore. But if you look at it, it took like 485 milliseconds of your CPU time. Okay, that's what happened. So now what I'll do is, I will do this and I will say run reorganize. Okay, this is an online command as Aaron was talking about. I'm going to run this command. Let me run it because it takes a little bit time. So what it is going to do behind the scene is going to go to those red guys who have a lot of deleted rows. It's going to create a new red guy. It can't just, squeeze it. It will copy the non-deleted rows into a new red guy and compress that. And the old red guy is pretty much ignored. And if you look at the output of this DMV that I'll show you, we say the status is tombstone. I mean, it's pretty much on its way out. Okay, that's the one way to see it, right? And now I'm going to run the same query that I ran before, and you will see it runs faster. Okay, so now remember I had one open and one closed, right? Okay, so I'm going to go here, and I'm going to run the row groups now. You see tombstones in the back? These are the guys who are dead now. We don't care about them. And you see the compressed rows? So everything that I did, deleted was gone. I got red guys that are fully compressed. I'm going to run the same query that I ran before. And I didn't even finish that. I mean, it finished. I mean, that's 4 million rows doing an average. I mean, just think about this, right? It's insane, right? I mean, you run a row store, it's going to take, you have to at least take a breather, right? Before it finishes. It just finished, ran. Okay, I'm going to show you the output. It ran that query like almost, because our thing is a millisecond time. Our clock, the thing we track, I can't say the English word, but it is the millisecond granularity, right? So it finished instead of 485. It is that kind of fasting. So what happens is, if you have workloads that are running slow, it was running fine yesterday or last week, my recommendation is, like you have done for regular indexes, look at the fragmentation. It can make a big difference. Now in this case, difference is very pronounced because I have half the rows deleted and half the not, right? But in real life, you will have 10–20% rows deleted, right? So it will not be as extreme, but something to be aware of, right? Now here is something interesting I found. So there was a customer. They called us. They said we inserted 100 million rows. Okay, they inserted 100 million rows, and they got 0 compression. Okay, think about that. They created a column store index, inserted 100 million rows, 0 compression, query performance not good. So they filed a bug for us. They called us, and what we did, we said, okay, I'm going to run this. The DMV that you see, this is my favorite DMV. Okay, this is literally my favorite DMV, which is, you guys know what DMV is, right? It looks at a lot of runtime information and the physical information. So the DMV that I want to talk about is where is this? Columnstore row group physical stat. It's telling you how those red and blue guys are looking. Are they healthy or not healthy? So we ran it. And we found out the customer had a 128 partition table, and 100 million rows were getting inserted, but none of the partition crossed the million threshold. Okay, so all guys were sitting in the open blue guy. Each partition has its own red guys and blue guys, right? So they had 128 partitions, right? And the data got distributed across all partitions. Now when you run the query, it will be slow because you are running the query not on the red guy, you're running the query on the blue guy. You're with me on that? Right? So that's the interesting example. In fact, I will show you one more interesting thing on this one. I have tried to simulate that same issue with a partition here, so partition data load, okay? So here what I did was, I created a partition table, factory cell or whatever, states underscore partition, okay? State shows that I partitioned by state. In my example, I created only 4 states. Okay, so now what I did was, I created the table, and then I imported the data. I created the column store index, and I imported the data. Okay, imported the data. You see that import here? I'm importing the data from a BCP, and I have to load into this column store, which is partition. And here's the interesting thing you may not know. I didn't talk about that. What is the batch size here? Can you read the batch size? It is 102400. This is a very interesting number. This is the minimum number of rows we need to compress directly during a bulk load. So bulk load is a special deal. We don't wait for million rows. If your batch size is more than 102400, we will compress that directly into red guy. Okay? Yes, they will not have million rows, but you can combine them using reorganize. Reorganize that I talked about even combines multiple row groups that are together can give you million rows. It can do many, many things. Okay? So I did that. So I'm expecting, well, I should get everything compressed because my size is 102400. And guess what happened? When I look at the row groups, everything is open. Everything is open. So you know what happened? The 100,000 that I chose had a distribution of rows across all 4 partitions. So each partition got less than 102400. So it landed in the blue zone. See what I'm saying? And that's why now you load 4 million rows, you run your query, it's running against the blue guys. It's not going to be fast. So my point to you is, before you go further, make sure your index is healthy. And this is not something like a new guidance because indexes do get fragmented. And think about that. Yeah? Okay. Any questions? I mean, I think I may be being too clear today. I just don't know what it is. Yes, sir.
I know that when he started in 2012, they were not updatable, and 2015 they were updatable.
2014 also not updatable.
Yeah. 2016.
Yes.
Yeah. But I know the cluster was updated.
That's right.
But some limitations at some point, if you have X amount of rows, then it will blow until you rebuild the index. So, I read an article from Paul Randall talking a little bit about, that if you create a cluster Columnstore index on 2014 or a non-cluster or something like that,
Right. Right. So I think your question is, can an updatable non-cluster column store becomes non-updatable? Answer is no, it cannot happen. But Paul is a very smart guy. He used to be at Microsoft. We work together. Maybe he is thinking of certain scenario that I don't understand. Let's do that offline. Yeah. So any questions? So this is that. Now the third thing that I want to show you, yes sir. Yeah. So computed column, you cannot create a non-cluster column store index today. That is a limitation. That is something that we are working to fix. And it is a very useful thing because you may want to do computations, and so you don't have to do aggregates and complex. Yeah, I agree. It's not there. It's not there. Okay. So the third thing that I want to show you, I have like, just 28 seconds left. Oh, we are over. Okay. Well, I have 3 more things. I'm just going to tell you at a very high level. Row group elimination is an important thing, right? When you have the data coming naturally in the data order, it gets eliminated because we have max and a min. But in many cases, you want to order the data in Columnstore. Now, question is, how can you do it? Because there's no key column. So what you do, dirty trick, you create a cluster Columnstore index, traditional on that column, data is sorted. Then you say drop that guy and create a cluster Columnstore index. Yeah. So the thing is, I'll just take 2 more minutes. I know you guys have to go. So you have to create a ordered clustered Columnstore index because it can give you row group elimination, right? Because you're doing queries in the range for that column. What you could do is you can say create a traditional cluster index on that column. It is sorted. Now you say create a cluster Columnstore index, drop existing. So it will drop that, but since data is already sorted, and a lot of people have done that trick, you do at the partition level. So I didn't realize the time is up. I mean, I thought I had 15 more minutes. I don't. Well, so we are going to end here, but there are row group elimination. There is also aggregate pushdown. There is also bad query plans. But at least what I talked about, I hope it was clear what Aaron talked about. And if you have any questions, you can get the slides and the demo if you have a USB drive in 2 minutes, or you can download it. All right? Yeah, I think all things are available. Guys, thank you so much and have a great afternoon. Take care.